Hello everyone, I'm Servinoz Abdullaeva and I will start our presentation. So our team's name is AI for Life and our team's main topic is Virtual Professor Assistant. And our team consists of 4 people. So let's move to the table of contents. So our presentation will consist of 4 main parts. The part 1 is going to be motivation of X and Y for the intelligent digital transformation model. And the second one is going to be its life cycle. Third one will be design and implementations. And last one is going to be open issue and the next steps. So let's move to the first one. In our case, X is the handwritten text recognition, and we combined it with ICT, and we came up with an idea of creating virtual professor assistants. So you may ask why virtual professor assistants? In education sphere, we have an considerable amount of problems that affect students' learning, and it of course limits the professor's ability to engage with more students. And in that case, in most national universities of Uzbekistan, there are not enough professor assistants. Even there are few of them, students are suffering from corruption, which leads them not gaining required knowledge. Even in pandemic years, in most universities and schools, we came up with these corruptions. For that reason, we came up with an idea of creating virtual professor assistants who can check, grade students' knowledge, and combine it with teaching them subject materials. And you may ask, what's the advantage of it? Firstly, it will help to improve students' ability to self-learn experiences, and it's effective in self-distancing during pandemic times. And it helps teachers with excessive workload and frequent questions, because teachers may not be able to check each student's homeworks and others. Of course, it requires a lot of time and energy from them. In that case, our virtual professor assistance comes in handy. So of course, it will lower the chance of corruption among professors and students. Thanks.
Hello, my name is Mihri. So I'm going to present the full life cycle of IE. Okay, let me show you. Firstly, we split this process into 6 stages as following. Firstly is problem solving. In this first stage, we are going to find good problem and give a meaningful solution. In our case, homeworks, assignments, online exams are the main means of analyzing and grading students' academic performance and understanding of the subject or covered material in all academic institutions. However, it is one of the most time-consuming activities of teachers or professors to manage and grade the answer sheets. The second stage is collecting the data. We are using existing data for handwritten text recognition from open source like MNIST database and Kaggle for our dataset. Third stage is unified dataset, which means we take above datasets and combine them in order to have a better unified dataset. And the fourth stage includes splitting up the data, where dataset can be split up into several groups, validation and test set. As we have a large database of data, we can separate them into groups. And in fourth stage, we train the data, which means to give them to our IE model to train. By using dataset of images of handwritten text, where model can improve its precision by having various appearances of the handwriting styles. We're going to use RNN and CNN models for our team project because we are mostly work with text and images in our project. Finally, after training our model with a lot of data collected during some period after time, it can be now evaluated further by using benchmark dataset by successfully testing by TensorFlow most likely using TensorFlow, which the model can be set to production, which means evaluating and deploying.
Hello everyone, my name is Shahzoda. Let's talk about the design and implementation. During the process of doing term projects, we create MNIST dataset from scratch, such as GNN, Adam Optimizer, value activation function, header initialization, dropout revelation. Also do experimental end-to-end design and implementation of the simple scenario for our application with TensorFlow. Here you can see our experiments with end-to-end. In order to do experimental end-to-end design and implementation of the simple scenario for our application with the TensorFlow, we start by importing necessary modules and load the necessary information. And we start loading MNIST handwritten dataset. This handwritten dataset helps us to demonstrate how text detection and prediction of letters or numbers work in our application. For convenience, we break down the data into test data, train data, and in order to pre-process the image, we create image data generator from Keras. Then, in the second slide, we use stochastic gradient descent optimizer and initialize our ResNet model to train the neural network and predict the values. And this part code is for demonstrating the output. This is end of my speech. Thank you for your attention.
Okay. So here in our part, I will talk about the open issues in our project and the next steps. So as you can see here, this data plays a key as a role in a use case. We just used three types of data collections in our project. We couldn't use them, and many of them. And then, so we, the second one is less training of data. So we couldn't training a lot of data because we had less data. So, and then, so we, after training our model, it's a lot of data collected during some period of time. It can be now evaluated by using the benchmark dataset. By successfully testing with the model can be set to production dataset. So unfortunately, we couldn't run our project application. I mean, because of the packages, some packages and libraries. So this was our main problem. So and now we don't give up, and we will continue to run it and for our next generation. So thank you for your attention.